I bet you've seen videos around where either a few magnets rotate around some coils of copper wire or coils of copper wire rotate around a few magnets, and in the process they produce electricity. But do you actually know how they generate those electricity? If you know, this is a chance to know more. And if you don't, now is a chance to know. I made a mini generator that can give up a few volts and can even light up this little LED. The purpose of this video is to let you know how electricity is generated other than making 1000 volts on your desk. Now, let's begin. To understand how electricity is generated, let's take a look at DC motors. This here is a small DC motor. This is a wire I soldered to it. Now, let's connect a battery and see it spin. And as you can see, the motor rotates. With this bigger motor here, it's pretty much the same thing. Connect a battery to the terminals and the current flows to the coil of wire that gets magnetized, and the magnetized coils react with the permanent magnets that are inside the motor to spin. This motor moves much slower because it is made to run at 12 volts. So anything this low won't get any good motion out of it. So far, we know that when you connect a battery to the terminals of a DC motor, current runs through the insides of the motor and rotates the shaft. But when you reverse it, you turn the shaft, the coils inside the motor passes the permanent magnets and then creates some current that gets sent to the terminals of the motor. Let's hook up a multimeter to this motor and spin it to see the voltage that would come out of it. As you can see, when I spin the shaft, it turns the wire inside around a stationary magnet and in turn creates a current or voltage if you like. You'll notice that even when the magnets and coils are close to each other, nothing happens till I spin the shaft. Therefore, voltage generation is relative to motion. The faster you spin the shaft containing either the magnets or the coils around the other, the higher the voltage you will get, and vice versa. Now, this right here is a generator that I put together, and on my first run it gave me about 50 volts, which is way more than I needed. But basically, this is how the inside of a DC motor looks like. Two permanent magnets by each side, 180 degrees from each other, having their north and south poles facing themselves, and then a configuration of copper coils placed in between them. You will see a copper contact called the commutator and two black metal looking things. They're not really metals, rather they are called carbon brushes. When you turn the shaft, the coils of wire rotate around the magnets, which induce a current in them. They transfer that current to the commutators that they are connected to. Those commutators transfer the current to the brushes, and you get a voltage reading out of the system. That's how a brushed motor can work as a generator. I used a drill to spin the generator, and to show you that voltage is relative to speed, the faster I spin, the higher the voltage and vice versa. It got to a point where the voltage coming out of the generator setup was greater than the 20 volts that I set the dial on the multimeter to. Then I had to change it from 20 volt cap to 200, and we can see the reading better, reaching up to 25 volts. I didn't run it for a long time because the drill was too loud. Now, seeing the basics behind how a brush motor or generator works, let's move over to how brushless generators work, which basically produces AC voltage. This is a few tons of copper wire that are wrapped around a battery to give the wire some kind of shape. I removed the wires from around the battery. I connected the wire ends to the multimeter and set it to read in millivolts, because something this small, I don't expect it to give me any useful voltage. I used a magnet and swung it around in front of the wire, and as you can see, it creates some voltages that the multimeter can read. But you should know that either the magnet or the wire must be in motion, else nothing will happen. Even when I pass the magnet through the wire, it still generates some voltage, and you will notice that it is a lot more than when I moved the magnet just over the hole as opposed to through the center. Now that we've established how movement of a magnet or a wire around the other creates a spark of some sort, let's go bigger. This here is a ton of wire wrapped around a metal bolt. Wrapping a wire around a metal bolt makes the flux that will come out of the copper to be directed into the metal and therefore increase the output. This is also how you can make an electromagnet. You can see that the bolt picks up the screw when current passes through the wire to create magnetism from the batteries. Just like the first one, you can see some amount of voltage is created, quite more than the first, because of the increased number of turns and the ferrous magnet inside it. Now, for this to work properly, you need the magnets to change poles to go from north to south to north to south. In that way, the AC flux can go back and forth as opposed to going in just one direction. To get useful voltage out of this, obviously, I won't spin the magnet with my hands. That is why I'll be using this DC motor from a cordless drill to spin the magnet. And first, I used a piece of tape to wrap around the shaft to increase the diameter a bit, because the piece of wood that I intend to mount the magnets on has a larger diameter or hole. After wrapping the tape around the shaft of the motor, I pushed the shaft through the hole on the wood and applied some glue from each ends of the wood for a strong bond, because having this run off from the motor is dangerous considering that I'm directly behind the camera. I got 8 15 by 5 by 5 millimeter neodymium magnets and I stacked 2 together for a stronger magnetism. I used super glue to hold the magnets 2 on either sides of the wood, and as you can see, the side that faces upwards is different from the one next to it, because one side is the north while the other is the south pole. I applied a lot of super glue and even hot glue into the holes of the magnets to ensure that none of them flies off when this motor would be spinning. I then got a piece of wood for the base of the generator and a plastic bottle cap to use as a mount or razor for the motor to avoid the magnets hitting the board while spinning or not spinning at all. I used super glue to hold it all down and sprinkled some sand grains on it for a stronger bond. I then brought the copper wires close to the magnets and used pieces of PVC that are melted flat to raise the copper to the horizontal level, same as the rotor, for better performance. Now, after gluing everything down, I went on ahead to add some wires to the motor, connect it to a battery and add a switch to put the whole thing together. I'm just going to breeze through it because soldering isn't what we came here to do today. After soldering the bits and pieces together, I connected the multimeter to the terminals of the copper wire and set it to AC reading. Turning on the switch, we can see that the generator got up to 4.5 volts, but I guess the vibration of the motor knocked it off the base. After frustratingly fixing it again, I got a lower voltage than the first, so I removed the copper wire and glued it back down again, a bit closer to the rotor, and that gave me 5.5 volts, 1 volt more than the first and 2 more than the second try. And got an LED light that apparently works both ways with AC and DC voltage. I connected it to the copper wires, and as you can see, it lights up. It's a bit lower than I expected because using a 3.5 volts gives off a brighter light than this AC 5 volts. So I thought maybe that's because it's AC. I hope this video helped you to know how generators generate electricity and how electricity comes to your socket. We'll draw the curtain here. If you like videos like this about explaining different systems and how they work, don't forget to like and subscribe. Thanks a ton for watching. Come back for more videos. I'm Emmanuel and this is Nexel Labs.